Good afternoon, everybody. Today we are discussing the influence of the temperature on the reaction rate on the basis of the correlation theory. Normally, when the reaction occurs by reacting the two different types of the reactant together in a reaction in a system. So here the figure shows that the red and the green one is the two different type of the reactant which is present in the reaction medium. So this molecule have an average energy, so this molecule will move and bombard with each other. But as the temperature increases, the kinetic energy or we are giving the energy to the molecule. So the average energy of the molecule, the energy of the molecule increases. That's why the number of the collision per second increases. The first figure which is presented in the left side of the slide shows the reaction which is occurs at room temperature. So in the next figure, that is the figure which is present in the right hand side, shows the increasing the number of bimolecular collision per unit time as we increase the temperature. So according to the collision theory, when the temperature increases, the rate of a reaction definitely increases. This is mainly due to the two factors. First one is the increasing number of the frequency or collision frequency, and the second one number of the effective collision. So collision frequency means number of the bimolecular collision per unit time. That is the collision frequency. The definition is very important. Now next factor is the number of effective collision. So the collision must be effective. For that, the bombarding molecule must have a proper orientation and having the energy which is necessary for the reaction. So normally the molecule are bombarded in an non or in an unappropriate way. So in the first figure shows that only two of the reactant molecule are bombarded in a proper orientation. In the second figure, that is the figure which is present in the right hand side, shows the number of effective collision, which are the molecule which are bombarding each other have a proper orientation. So now look into the A. Here there are two reactant. One is in the pure form. So second is the combined molecule, a molecule. So in the A, the collision is effective because the green balls are bombarding in the same direction. So the energy of the both the molecule will share. So that's why the reactant is occurs. The product is formed and the other molecule is eliminated. So the product is formed in the A. But whereas in the case of the B, the collision is not effective because the colliding molecule will not share its energy. That's why there is no reaction occurs. So the colliding molecule must have the proper orientation. And the next point is every molecule must have the energy which is required for the reaction. So first of all, every molecule have an average energy. So that energy is not sufficient for undergoing the chemical reaction. So we have to supply some energy to which is required for the chemical reaction. So the threshold energy is the energy which is required for the actual reaction. That is shown in the figure, the threshold energy. So but the normally the molecule must have a average energy, internal energy, that is also shown in the figure. So we have to give the energy which is required for the threshold energy, that is the energy which is given to the molecule is the activation energy. So by giving the activation energy we have reached in the threshold energy, and then the molecule will undergo, or the recent formation of the intermediate, sometimes the recent formation of the intermediates occur, Then finally it will release its energy and break down the bonds and to form the product. This is the kinetic theory of the chemical reaction which is occurs during increasing the temperature. Thank you.